new version here. Alright, so in this new version, staying the same so far, what I did here was I'm setting another class level attribute to the path, the full path to that UI file, which is in the Qt folder. But for the purpose of this example, I'm also using this special version that will relatively find it to this file so that you don't have to worry about paths, but you could just set the full path right there and comment that out. But we'll use my version for now. So this will find it in the same directory. The init is relatively, actually should be the same. Let's look at the differences between those two. They should be the same. And moving on here, asset import window is the same here. Now, instead of the whole creating the windows shindig, we use the commands load UI, and we load, the file is the UI file that we set right up here. And that will automatically generate the window for us, so we have the entire window with the entire UI. The only thing we didn't set up, and this is the bit of the hack that I was talking about, is because we want to be able to work with a layout tangibly, whereas in Maya you would work with widgets in the layout, but we want to add dynamically. So what I did here was I got the path to the library layout, and that's actually the name of the window, main layout, library frame, library layout. Now, how did I know to use this path? Well, let me show you what I did here. Okay. And what I did here was I loaded in the window, right? And I got the name of the window. And then I did a loop. And what I'm using is the LSUI, which lets us list UI components. And I have a flag here that says dump all widgets, and this will dump every Qt widget in the scene. And I say if that specific widget has our window name in it, print it, and you'll see what happens here. We get a list of, these are all our widgets that got made for us when we made the widget, the window widget from the UI. And if you see here, here's our delete me. Now, when I said I had to put this in here, if I hadn't put this button in here, you tend to not even get these layouts exported. So we need where this location is to start adding our all our assets. So let's go back over to the code here. And so what I did was I got that path, and then I'm going to create my own grid layout in the space where the button is. So, and I call it library, just like in our previous code. We had library creating a grid layout. It's exactly the same thing. And I parent it to the library layout that I just found. And then I delete that button. So you see why I had to make a placeholder. If I hadn't, I would never have had this path to reference. It's kind of strange like that. And then that's all I do is I just save the window, the library, and I have this new little function here. This is new to this file called getUI. Let's jump down here and see what it does. This is just a special little helper that helps me find the widgets, the UI widgets, by name. What it does is it's that thing I showed you before where it gets the dump of all the widgets, and it looks for every item in the list if it's part of our window, and if it's part of our window, then we grab it. So this gets all our widgets in the UI, and then I go through each one of those items, and if it ends with our name here, then I grab it. So it's an easy way. Let's go back up here to show. For me to just say I want the imported list, because if you remember from our Qt file, this is our imported list, and I just want to get it by name. So now I can just say get UI by name, and now I've got the widget, and that's very similar to where we just created our imported list from a scroll list and then saved the name. And then down here I set up my connections. and just like before, I set up the button and I get the UI. Instead of knowing the name ahead of time, I just get it from the name we named it in the Qt file, and I point it to refresh assets. So this part is all the same. If you see that when I switch over here, this is all the same. All I changed was how I got the name. Instead of having to create these by hand, I just grabbed the names of them and connected them. So all the code, except for this new function, all the code is all the same. I never had to change the way that these refresh assets, refresh imported, that's all the same. And it reduced our code significantly and made doing the layout a lot easier. All I had to do was load the UI file, and in the case of our application, just create a couple more nodes, and that's it. And let's take a look at what that actually looks like. I'm going to create a new scene here. Just make sure we're good to go. Clear this out. Alright, and if you remember, we've got our path, okay, on there. And the location of the file, if we pull up our Finder, is, now we've set code to be our path, so it's asset importer Qt, and then asset importer win. So let's do that. Let's say from asset importer dot Qt. Let's look at this again. Asset importer win, asset importer win, import asset, and we called that. Let's check and make sure. Always have our code as a reference. Asset importer win. All right, now we've got it, and all we have to do dot show. Let me hide this here. Oh yeah, that's right. We didn't set up the show function. We don't have the convenience show. Let's just create our own instance of it. So let's say, oh, that's because we imported the actual class. All right, we'll just do it like this. We'll say win equals. We could have imported it up to here and then said show. But let's just do. Now we've got an instance of our window, win.show. And there we go. This is our asset importer made in Qt. Let's see if we can make some room here. And some differences is it's a lot easier to set up the way that the layout works and attaches to everything, as opposed to having to do convoluted UI commands. And let's close this here. And you can see it works just the same way. We can refresh our library. We get all our assets here, and we can import them. Sorry, my Maya had a little bit of a problem. I just had to restart it, but we're back to where we were with the imported items. But we can hit this button and we get the list, and we click on each one and it changes the selection. So you can see that the functionality is all the same, yet it was much easier to create a UI. And you can imagine if you wanted to create much larger interfaces with rows of toolbars and lots of widgets, and it's so much faster to create your UIs with Designer, even with the ability to set, like we said, the dynamic properties down here at the bottom, which the Autodesk videos kind of show you how to do, but I kind of find it somewhat limited. So you can only do so much with this, but if you really want to blow the doors off this whole thing, you should move into the idea of using PyQt, which lets you define all the connections, all the buttons, everything through signals and slots, which are ways to hook up events to callbacks. And we'll get into that in a bonus tutorial. But this was how to create the Qt Designer. You can download it and give it a try. This segment of the tutorial is where we start pushing into the advanced category of Python and Maya, and that's because we're going to look at the API. And the API, like I said in the previous chapter, is very C++ style, It's less Pythonic, so it takes a little bit of adjusting. So I think we're going to start with some very simple API examples and not really get too deep into it. That can be some sort of later video. But what we'll do is we'll pull up an example, and in the code plugins directory, the first thing we want to look at is the simple command. And let's pull this up here. And there's a couple different types of scripted plugins that you can write. And the most basic of all of those is a simple command script. It's very similar to all of the other scripts we've written. And the only difference is that this gets loaded in as a plugin, and it would be available on the Mel or the Python side as a very natural command, such as if you were to write commands.myCommand, you would have access to your plugin in that form, as opposed to having to do a long import statement and make your objects. Maya loads it as an actual native plugin. There's a couple extra reasons that it's beneficial, is that you get more access over the undo, redo type system, and but pretty much you're not going to get a huge benefit because you can still use these in a normal Python script. So let's just take a look at it. What this is not a complete script. This is a template that I put together so that you can see with lots of comments of what everything does. So let's go through this bit by bit. As you saw before, the way to access the API in the Maya, instead of using the commands module, we can use Maya, open Maya, and we'll just bring it in as open Maya namespace. So now we have access to, these are where all the objects live, the various objects. And then open Maya MPX, these are all the proxy objects, and we'll see what those are in a moment. This is what we template our new types of objects off of. And then we'll need the sys module, the standard Python sys module. So one of the first things you do when you're writing a command plugin is you would define some constants, and the C++ form of doing that is putting a k at the beginning of your variable to note that it's a constant. And right here we're just giving it a plugin name. This could be anything, but for readability we're saying k plugin command name. We're going to call this command a simple command. So we start our class, and we can call this again anything we want. I'm calling it simple command. And what we inherit from to create a new command is in the proxy module, there's the MPX command, and this is the base class for creating a new command. And what you always want to do is define your init. Even if you're not going to do anything here, you need to define the init and call the superclass so that it gets set up properly. Now, the one of the most important functions, the methods that you need to know about in a command is the doit method, and it has to be case sensitive just like that. What you're doing is you're overloading your own doit, and this is at the very, very basic level where you would do everything, all your functionality. You get the arguments coming in through here. Maya gives you all the arguments from the selection, and then you can use those, you can parse the arguments and run your actual command right here. All I'm doing in here is I'm just writing out to the script editor, just that we got into the doit method, and that we would be, and then it's just going to print hello world. Now, if you wanted a more advanced plugin that supported the undo functionality, what you would need to do is you would define this undo method is undoable, and it just needs to return true. So if this were a command that supported undoing, you would just need to return true, but I'm going to put it false, or we don't even need to have it here, but just for your readability I'm putting it right here. And that would be really at the basic level, all you need is this. And what you get is, and let's take a look at what that does. Now if you remember, I'm going to pull up my shell one more time. In a previous chapter, I went into my Maya env, and I set up these basic environment variables, and so we have the plugin on the path. So I'm going to go back into Maya, and I'm going to pull up the plugin manager. Alright, and so we have, it sees some plugins in our path. I'm going to load the simple command and close this, and you can actually hit info and it tells you what command came in. So this is the command that came in, simple command in those caps. So if I do commands dot simple command and run this, you see what happens, that I can run this just like any other native commands module command because we created a new one. And all it does is it prints these two lines that it got into the doit method and then it ran hello world. So let's look at that again. These are the two things that happened. It takes care of everything else with the function or the setting up, and it just calls this for you, as opposed to you having to call any kind of functionality. Now let's go down here at the bottom and look at the other required elements of a command script. These are boilerplate commands. Let's give you a little more room here. You could basically copy and paste these into any command that you're writing. The default things you need here is this command creator function, and this is a function that Maya is going to look for specifically in order to know how to get a new instance of your class. All it has to do is use this Maya proxy as Maya proxy pointer, and it just creates an instance of our class from up above and returns it. And you can pretty much just copy paste this, switch this out for your class name, and you're good to go. Then this is optional. This is a syntax creator. If your plugin, if your command takes any command arguments, then this is where you would set all that up. And I'm not going to do this right now because it's not really necessary to get into this, because if we wanted to write this function for our asset importer, pretty much all we would have to do is just paste the functionality into here and make doit call the asset importer. We don't really gain anything. But you can see this template is how you would set up a command. And this is the area, again, where you would define flags, but we're not going to do that for now. I just want to show you the template. And it returns a syntax object. This syntax object would, under this section, be populated with your flags. The last two pieces of necessary functionality is the initialize plugin and the uninitialize plugin. These are called when the script is first loaded, that is, when we go into the plugin manager. When the script is unloaded and loaded, that's how it initializes and uninitializes the plugin. And again, all you have to change, what it uses is the proxy class. It defines a plugin and it wraps an M object, which again you don't need to worry about. But right here is where you could say the author, the version of your script, and the API compatibility that it requires, but you can just leave this as any for now. So really all you would change is these two things right here. And the rest is boilerplate. This is registering the plugin by the name that you gave it. See, this is where we define the name. If we go back up to the top, this is how it gets the command name. And we just pass that right down here, along with our command creator and our syntax creator. So it completely knows how to register this plugin. If it can't register the plugin, it's going to fail out with the name of the plugin. Same thing down here, and there's actually nothing to edit. So if you were just to copy and paste these, you're good to go, and just fill in the doit section right here. So next, what we're going to look at is we're going to create a new node. And again, we're going to take this up a notch, and we'll just try to follow along and keep it really simple. So let's go ahead and let's open up the other file that we have in here, the shake node. And there's a lot of documentation in here as well for you to look at later. But let me go through what this is going to do. Actually, I'm going to go ahead and load it in and show you what it does so that we know what we're talking about here. I'm going to go up to the plugin manager, and I'm going to load it. Now, if you set these obviously to auto load, you wouldn't have to keep doing that. And let's go ahead and get rid of this. So what I'm going to do here is I'm going to say shake equals commands create node. Shake node. Right? We create this, and what we get is this new node, and it's called the shake node. And what we've defined on this shake node is amplitude XYZ, frequency XYZ, an attribute called octaves, and an attribute called random seed. And this is a dependency graph node. It's something that you can connect the output of to the input of another function that would receive an XYZ attribute. And what this would do, and I can go ahead and paste in an example here for you to check out. Okay, and I'll explain what this does in a moment. So what I'm going to do is I'm going to just run this. All right, and let me close this for clarity. So what we've got here is a sphere. Let's put this in, see a lot of frames here, and let's see what it does if I hit play. You see that this is shaking around here. It's modifying the position. So let's find out. Let's see, go open the script editor here again, and let's select the shake node and take a look. And it's connected to the time module, so it's constantly getting the current time, and it's shaking it over time. And let's select the sphere again and see where it's being driven. So you can see right here, these attributes are being driven. If we stop that, you see that the translate's connected to it. So this is just a very generic node, and if we open up the hypergraph connections, we can see that we have the shake node connected to the NURB sphere translate. Let's open this here. Right? So all we're doing is creating a dependency graph node. It does not show up in the DAG. It just shows up in the connections. So let's take a look at what the code actually does. Okay, so this is a dependency graph node, and what we're inheriting from in this shake node is in the Maya proxy module. It's called MPX node, and if we open up our documentation that we had earlier from the API reference, and if I go over to search and I search for the MPX node and I pull that up, we find out that the MPX node, it's the base class, the base parent class for any type of dependency node. So any kind of new node you're going to make, you can inherit from that. And here's a little graph showing you how that's laid out. You have the MPX node and all these other types of nodes that inherit from it, and then nodes inherit again from those. So if you wanted to get more advanced with a transform node, which we were actually kind of making, you could inherit from this, but we want to just try the most basic approach. This is at the very least what we need to inherit from. So let's open up the code again and go through this here. So here is again where I set my node name, and you can see that this is slightly different. I could call this anything I want. It's a plugin node name. We're going to call it shake node, and we need the OpenMaya and OpenMaya MPX as before, and then I've got the basic math, sys, and random, and we're going to use the random module to generate random shake. And if I could just give you one more example, if I actually I don't even need to uncomment it. I'll just select this, and I'm going to select the sphere, and I'm going to bake this out. Let's wait for that to be done. Okay, now let's take a look at the graph that it produces. You can see that what we're generating is a noise curve, and with randomized points. And what happens is we have the large scale randomization, and then we have these finer randomizations. So we want to be able to control large frequency and the smaller frequency. So this is the goal of what we're trying to produce here. And you can see that the X, the Y, and the Z are all different randomizations. So we want to keep those so that you don't get the exact same motion on all axes. Let's go back to our code and see how we do this. So the next thing that we need, and this is required by Maya when you are defining a new node, is you have to define this type ID. And what the type ID is it's a hex number, or just a large int number, and we can see the definition of that in our documentation. If I go over here and I search for the mtype ID and take a look, we'll see that what happens is this range right here, these first amount of IDs are internal to Maya, and that defines all the nodes that Autodesk has provided. But then you have this other range right up here, another set of this many IDs that are for development to create with. And for our purposes, if you're internal, you can use any of these numbers. So say you're developing at your company and you're not going to be distributing any of the scene files, it's all internal. You can take any of these for your internal use. But if you're going to be distributing to everybody in the world, then you have to actually contact Autodesk Developer Network like this and request a block of IDs that they give you. And the reason for that is because when these nodes get written to scene files, they actually get stored with these IDs, so that when you go to open the scene again, it looks at the ID and it matches it up and makes sure that it's actually using the right node. Because if it were to use, say I have a node called Shake Node and someone else writes one called Shake Node and they open it up, their Shake Node may not be like mine, and it may not work and break the entire scene. So if they do it by ID, they know that if these IDs match, then it's the right kind of code to expand this out to. So we create our ID, and then we come down here and we inherit from MPX node. And the first thing I'm going to do is set up some attributes for my node. And if you noticed in Maya, if I bring up my node here, let's see, select Shake, we've got these attributes that we set up. And we define those slots right here as class nodes, and we just set them to open Maya M objects. And M objects, like we said before, is the most basic handle to an object that Maya would own. So these aren't set up yet, they're just handles, and they're here to be set up at a later time. So these are my input attributes, and then I'm going to have one output attribute, which is going to be an XYZ data. So we set up another M object, and as usual, we inherit from the superclass, which is from MPX node. And then the most important item that you need in your node is the compute method. And what compute is whenever a plug on your node is needs to be evaluated, it will call this method with the plug that's in question and all the data that's available to you about all the attributes at that moment in time. And the rule of thumb is that when you do this compute method, you're only supposed to use data that was given to you from this data block. You can't be calling out to other scene data because you don't know what moment in time that it's valid. So all your data needs to come in through this data block. And what we do is, in our case, the only plug that we care about checking is the output. We only want to know if we only need to compute the output node. Everything else is going to be set from another source. So we say that if the current plug is self.output, because we're checking if the plug being given is equal to this attribute, then we're gonna use it. Otherwise, we're not going to do anything. So this is the only case that we use. And this is where we grab all of our data about this current moment in time where we're computing something. We look at our data block and we ask for the input value, and this is where these attributes come into play from up here. We set these handles, and so we're going to use these handles to pull out our data. So we say input value for this attribute, and we need to convert it to a float 3. And I'll explain these coming up in just a second. So we want this to come out as a float 3. We want the frequency to come out as a float 3. Time is a time value. Octaves is an int. Seed is a long integer. And seconds is where we take the time and we convert it into actual seconds. So let me give you a little more detail on what's going on here. Let's move this over a bit. Actually, let me jump over here. What you can see is that amplitude has 3 values. This is a 3 float attribute. So if I want to get the results of this amplitude, I need a 3-part float as a tuple. And then same with frequency, I need a 3 float. And then for octaves, it's only integers. So I just need 1 integer. And again, I need a long because this could be a very large integer. Now, where does time come from? Well, time is attached as well and being driven, and I'll show you where time comes from in just a second. Okay, so before we go any further in here, let's jump down to the other needed functions before we get into how this node or this